Okay, today's lesson is A99. We're solving systems of equations by elimination, part 1. What's our objective, class? Get ready?
Solving systems of equations by elimination, part 1.
Good. So far we've solved systems of equations by 2 different methods. Give me a thumbs up if you remember when we did solving by substitution. Okay, most of you. Okay, how about solving by graphing? Okay, good. We found out where the 2 graphs intersected and we substituted one variable into the other. Well, today we're going to learn a third method. It's by elimination of how to solve a system of equations. And it starts with this premises. The left side of the equation equals the right side. This is a balanced equation. Picture it on a scale. So if I were to put this on a triple beam balance like in science class, the left side would be balanced with the right side. Same thing with A equals B. If I've got 2 things on the scale and they're balanced, if I add 3 pounds to the left side, I need to add the 3 pounds on the right side as well to keep it balanced. As long as A equals B and 3 equals 3, I can add the 2 together. So what I would end up with here, if I added, I'd have A plus 3 equals B plus 3. We're going to do that type of method with the elimination method in a system of equations. So take a look at this equation. The left side balances with the right side. And here's a totally separate equation. This left side is balanced with the right side. So here's my question I want you to consider. If the left side here is balanced with this right side, this separate equation is balanced with 4, could I take all of the weight off of this side of the scale and just stack it on top and add it to this side of the scale? Take this weight and put it on this side of the scale. Would the scale still be balanced? Give me a nod if you think it is. Yes, okay? As long as that equals that, and this equals this, the scale is still balanced. So we're going to use that mathematically. I am actually going to take these 2, and I'm going to add them. What happens when I add them? Okay, let's add the right side first. 16 plus 4, think. Okay, ready? 20. Let's add the left side. This one's going to be a little different. We have 2x plus 2x. I can only add like terms, so 2x's plus 2x's gives me 4x's. And then I've got something kind of interesting going on right here. I have 3y plus a negative 3y. Well, they have the same coefficient, the same variable, but this one's positive, one's negative. And I would know, oh, plus 3 minus 3 equals 0y, so they eliminate. That'd be 0y, which is just 0. That's why we call this the elimination method. What do we call it? Get ready?
Elimination method.
The elimination method, because 3y and negative 3y eliminate. So all I'm left with is 4x equals 20. Well, now that I know that 4x equals 20, I can quickly solve for x, which is, think. Get ready? 5. Perfect. Once I know one variable, I do the same thing that I've done before. I pick one of my equations and I put the x back into the original and solve. So I'm going to write down our original equation. I'm going to put a 5 in for x. 2 times 5 is 10, plus 3y equals 16. We're going to subtract 10. I'm running out of room. I'm going to come right down here. So those cancel. I'm left with 3y equals 6, because 16 minus 10. And then what times 3 would give me 6? Get ready?
2.
2. Good. So y equals 2. So my solution set is 5, 2. I can write it as an ordered pair, or I can say x equals 5, y equals 2. Either one is okay. So again, that was the elimination method. We're going to do a few more of those. Joseph. 16 was on the other side of the balance scale, right there. Okay, I guess I kind of wrote it a little to the left. All right, so we did that. We did that. Okay, so we talked about this is the elimination method. Let's review the steps. Step 1, we added the 2 equations together. And what that did is we had an elimination pair that canceled out. Okay, they got eliminated. We made a third equation and we solved it for one of the variables, then we substituted into the other equation. You guys can't see because all this is there. The last step would be to do a check step. So we're going to do the check step on our next equation. So let's try this one. 2y plus 3x equals 7. And our second equation, negative 2y minus x equals negative 9. First step, look for an elimination pair. What am I looking for? Get ready.
Elimination pair.
An elimination pair. An elimination pair has same variable, same coefficient, but one's positive, one's negative. So my elimination pair, Spencer?
2y and negative 2y.
2y and negative 2y. So that means I am ready to eliminate. So I stack and add. What operation do I do? Get ready?
Stack and add.
Stack them together and add them. I line up my variables. They're already lined up for me. So 2y plus negative 2y is 0y, so it just goes away. It's eliminated. 3x plus a negative 1x is 2x. 7 plus negative 9 is negative 2. I divide by 2. That gives me x equals negative 1. So my next step, what do I do? Okay. What do I do to find out y? Tate.
You would check you would run through the equation.
Say it again.
You would put the negative 1 through the equation.
Put it back into the equation. You get to pick. Do you want to do the top one or the bottom one?
Bottom.
Let's do, I would agree, because it's got a little less numbers in there. So I'm going to rewrite it right here. Negative 2y minus x equals negative 9. In place of the x, I'm putting a negative 1. So right there, I'm putting negative 1. Be careful. It's a negative, negative 1, negative, negative 1, which becomes a positive 1. So now I'm going to isolate y, subtract 1, subtract 1. This gives me negative 2y equals negative 10. Good. How do I solve this now, Bethany? Divide 10 by 2. What about this negative, though? Yep. Since they're both negative, I can make them both positive by like timesing by negative on both sides. So you said divide by 2, divide by 2. 2's cancel. I'm left with y equals 10 over 2, which is 5. And now I've got my solution pair right here, negative 1 and 5. Any questions? Okay, we got 2 more. I'm going to let you try on your paper. So here you go. I want you to copy down the system of equations. 2x plus 3y equals 20. And negative 2x plus y equals 4. Copy that down, show your work, and give me a solution pair for x and y. Raise your pencil when you're done. Okay, I didn't get almost to everybody, but I saw tons of right answers. Emmy, what was your answer for x and y?
I didn't get X, but I got Y.
You got y, what was your y?
6.
Y was 6. Raise your hand if you got y equals 6. Okay, almost all of you. Just a few of you didn't. Let's check it real quick. Emmy, did you stack and add? What did that give you when you stacked them up and added?
Like the equation,
Yeah. What was your new equation?
it was 4y equals
4y equals 24. Will, where did the x's go? Because I had 2 kids in here that thought it was 4x right here. They canceled out. Plus 2 minus 2 is 0. 0 is 0, so we don't even have to write it. We just eliminate it. That's why we call it the elimination. We eliminated the x's. And then I had a few students that did 3y plus y was 3y. If you put your 1 there, that will help you. Okay, 3y's plus 1y's gives you 4y's. All right, and then what do you do next, Emma? Emmy? Divide both sides by 4. Perfect. There's your 6. Okay? And this morning I saw some 8 answers. So just check your multiplication. Be careful. Okay, what do I do with the y equals 6? Joseph?
You put it back into the equation.
Perfect. Which equation do you want to use? Go back to the original.
The top one.
You want to do the top one? Okay. So we'll go 2x plus 3 times 6 equals 20. That gives you 18. How do I solve it from there? Dakota? I gotta eliminate, or I gotta isolate x.
X equal 1.
Okay, did you do it mentally? That works. 2 times 1 is 2, plus 18 is 20. You can do, that's guess and check, that works. You can subtract 18. You get 2x equals 2, divided by 2, x equals 1. And there's our solution pair. Okay, and these turn to click. All right, I think we're gonna go one more set and see if we can get 100% of you to get it. So here's your next system of equations. Write down 7x plus 4y equals 2. And 9x minus 4y equals 30. Identify your elimination pair, stack, and add. Okay, great job. Let's see. Dakota, what did you get?
X equals 2, y equals negative
X equals 2 and y equals
negative 3.
-3. I think he's right. Let's check it. We add here 16x. Now be careful. Just because the last one, these ones eliminated, the only ones that eliminate are the ones that have same coefficient. One's positive, one's negative. I should circle the coefficient. And the same variable. So these are my elimination pair. What are they called? Get ready.
Elimination pair.
The elimination pair has the same number, same coefficient, different signs. So these guys eliminate. That's 0. I'm left with 32. Divided by 2, x equals 30. Now I go back into the original. Dakota, which equation did you put your 2 back into?
Top.
The top one? I remember.
When would we use this?
We have 2 equations, 2 unknowns.
For what jobs?
Lots.
For what?
Okay, so we get 14 plus 4y equals 2. Okay, we subtracted 14, we get 4y equals, what's 2 minus 14? Hiram?
2 minus 14 is negative 12.
Negative 12. And then to solve for y, what would I do? Alex? Glacier? Divide by 4, good. Okay, they cancel, and then there's my negative 3. Hey, we didn't do our check steps. Let's do a quick check steps. Hiram, how would I check?
You put it into the equations.
Which one? Oh, the equations, both. So I could take the top equation, put a 2 in there, put my negative 3 in for y, and say, does it really add up to 2? 14 plus negative 12. Sure enough, that adds up to 2. How about the second equation? 9 times 2 plus, whoops, minus 4 times our y is negative 3. Should we be talking?
No.
No. Negative 4 times negative 3 is positive 12. Does that add up to 30? Check. It does. 30 equals 30. So there's our check step. So question is, when do we use the graphing method? When do we use the substitution method? When do we use the elimination method? So I'd like you to get your notes ready. I'm going to write you down the answers to those questions. How do we know when to use the elimination method? You will use the elimination method when you have an elimination pair that will cancel out. Okay? So when you have an elimination pair, when do we use it? Get ready?
When we have an elimination pair.
Very good. When we have an elimination pair. So if you want to put that in your notes as an example, you're looking for same coefficient, different signs, same variable. Okay, question 2. How do we know when to solve by substitution? Solve by substitution when one of the variables, so you might have a system like this. When one of the variables is isolated. Okay, so you use substitution when one variable is isolated. When do we use substitution? Get ready?
When one variable is isolated.
Good. When one variable is isolated. So you could either write this example, or you could say one variable is isolated. All right, next, the last question is when do we use graphing? When do I solve a system by graphing? You should use the graphing method when you've got 2 equations that are in this form. When you have, who remembers the form that this is in? What's the name of this form when it's y equals something x plus something? AJ?
Slope intercept.
Slope intercept form. What form is it, class? Get ready?
Slope intercept form.
Very good. Slope intercept form. So it's the y equals mx plus b. So when it's in this form, it's a great time to graph because we can graph that really easy. Intercept, rise, run. Intercept, rise, over, run. And then you can whip it together, a little graph, find out where the 2 lines intersect. Okay? So those are your 3 scenarios of when you solve by a system of equations. All right, we're on page 821. You've got 20 seconds to end up break.